Okay, so the $1,000,000 question is always the question that bugs a lot of minds, which is what is reverse engineering? How can we really define what reverse engineering is, and is it really that interesting to begin with? And the question is, the answer is, so reverse engineering is this art, this mystical art of breaking down things. So if you have stuff like, let's say, if you have a VCR or you have a telephone or you have, a machinery of some sort, and you're trying to understand how it works, you're pretty much doing reverse engineering. And so that also applies in the space of software engineering. So we are surrounded with applications, we're surrounded with programs and technical modalities all around us in different places and different mediums. Whether you're in the car or whether you're traveling, almost everything is being controlled by software. So a big aspect of understanding how these things work is to start by understanding how software works to begin with, and then you can make your way and understand those tricks and pieces that really fall into the same basically bucket. Now, what is so special in the last couple of years is that there's a new threat that is coming up, and it's called ransomware. A ransomware is basically a malware system, or it's an application. Think about it as an application that tries to it tries to basically blackmail you into paying a ransom for your data. And now you would say, okay, how is that possible? And what is the threat here? So the program, when it runs on your machine, the whole purpose of the application is to encrypt your data. Now, there are multiple ways in achieving that. You either encrypt the files themselves individually, and that takes a lot of time, it takes a lot of effort from the application itself. And sometimes you can really stop the operation, and you can get away with most of your files if you're really lucky. But there are really, let's say, there are other means as well, and other mediums that have, the hackers and crackers, have used across the years. And one of them is to encrypt your partition table as well, which makes it much easier and faster. And so the ultimate purpose here is to encrypt your data in a very difficult fashion that you can't, decrypt your data going forward. You have to pay a ransom in a specific payment method, and we're going to get to that in a second. But the idea is you want to get that password again that we call key, if we're talking about technical terms here, and then you want to use it, you can get your files back. Now, what is so special about this new threat is that a lot of companies, it's very apparent now that a lot of companies never thought about cybersecurity when they started their business, and that really span businesses like banks and things like TV companies and such. And I've also had firsthand experience dealing with big TV networks in the Middle East. Probably the biggest here in the Middle East that has had the same experience, and I had to work with them, in order to see what we can do. But for the most part, most companies that are hit with ransomware are, it's very unlikely that these people are gonna, pick up their files without paying the ransom, honestly. So yeah, just to put it in simple terms, it's an application that does a pretty good job when it comes to encrypting your data, and then it blackmails you into paying that sort of a thing. Now, what's so funny is that the blockchain space, but things like cryptocurrencies, namely Bitcoin, has been a great medium for those hackers to operate. Things like Bitcoin, Monero, and the other cryptocurrencies, because of their nature, which is extremely difficult to track in most cases, not impossible, but extremely difficult to track, allows those hackers and those crackers and those bad people basically to establish a business, with a very healthy, which is funny, again, a very healthy business model to operate in the dark space or in the dark web specifically. So what these people do is that they ask you to pay the ransom through one of those channels, either in Bitcoin or one other, cryptocurrency. So it's all in all, it fits really nicely. You have the payment method working for you as a hacker, and you also have this really great and a very easy system that tries to abuse other people. So this is the whole purpose of this session. I'm going to try to tell you exactly how that happens, in technical terms. Okay, so just recapping on the same subject, reverse engineering is this skill of allowing us, it is basically the skill of understanding how to tear things down and understand how they work, from the inside out, which is pretty interesting and important, especially in the field of cybersecurity, because everything that we do online has, security ramifications basically. And big companies like Kaspersky and in the other one like Symantec and such, in order for them to understand the threats and analyze them, they have to have people who are really good when it comes to software, people who can dissect software and understand how it works and understand the intention behind it. And this is where we come in. So if we're talking about this, even though the priority today is understanding how software works for, a security for a security goal in mind, but that also means that we can use it to understand, how things basically work just for the fun of it, or if you want to port code to other platforms. So imagine you have a game that works on Xbox, for example, on the Xbox, and you're trying to port it to the PlayStation 5, for example, for the PS5. You wouldn't be able to do that unless you get the source code, but another way is to dissect the original binary or the original program on that source platform and then try to replicate the same behavior on the target platform. Again, as we said, stopping malicious code is a must, and you can only do that when you're extremely good with software. A good example is, just to reiterate on the idea, is the Microsoft Connect, which has been a very popular tool for the people who acquired the Xbox 360. And it was this proprietary device that you can only enjoy if you have an Xbox. But believe it or not, this device has been, under the challenge of the community, and a lot of people managed to, get their hands on the device and really break it down and get it to work even on really, fun platforms like on Linux or even on Windows. The other aspect is ransomware. So this is a very great example here. WannaCry, a very notorious ransomware that has been abusing people for years. And the idea is here, when it gets run, it manages to encrypt your files, and you have to pay. And what is so crazy about that is that you have a specific time frame that you have to operate against in order to save your file. So it's exactly what you see in the movies. The only downside here, the hostage, in this case, is your data. So to be a good reverse engineer, you have to be extremely good with software, and there's no way around it. So if you hear about people getting, their skills leveled and sort of thing, you'll have to understand that they're really good with software. The way things work, and it's probably now, you have machines and hardware, and these devices, they don't operate on their own. They're basically chips, and they're finite state machines, devices that operate under the control of what we call software. So back in the day, you had to actually program those devices to do one single task, and that's that. Now, in this modern age, you have a very powerful program that goes by the name of the operating system. Things like Windows and Linux, they operate in the space, and their ultimate duty is to create this abstraction layer that isolates the users, because people in the security space are always paranoid, and whoever develops operating systems is no different. So when you develop an operating system, you should always suppose that users are going to be malicious. So when you develop an operating system, just remember that you're going to put controls and use cases and everything that allows you to, basically protect your users from each other when they abuse the computer resources that you've got. Eventually, on top of that abstraction layer, you've got your normal applications, everything from your word processor to your browser, to your games and everything. They all operate under the control and the jurisdiction of the operating system. And then you get things going. But just remember, the operating system is the ultimate, let's say, supervisor for the whole show. Now, in the software computer world, and in the software world, basically, you have multiple programming languages. You probably heard about this in terms of religious wars. You have people who vote for C, C++, myself included, and you have people who go crazy for Python if they're interested in machine learning, in IoT development, for example. But the million-dollar question again is, is there a language that really, that can win above all, or is just like more of a preference? And the answer that I acquired across the years as a professional in this field is that you don't want to be a fanboy. You want to make sure that you have the right tool for the right job. And so if you program, let's say for the machine learning space, you're probably going to use Python because this is what the community favors. And if you're going to develop for low-level systems, you're definitely going to go for assembly or C, C++, depending on your use case and the level of control that you need. And so when we're talking about programming languages, you've got basically two specific genres, let's say genres, if you're into music. The first one is called compiled languages, and the other one is called interpreted languages. The difference is pretty simple. So first, in C, C++, or one of those languages like C# or Java, pretty much, the popular languages that you find in the corporate world, in banking mostly. And their flow is pretty simple. So you develop using those languages, and then you have a piece of software that goes by the name of a compiler, and its ultimate duty is to just translate that code that you write in an English-like language, like C, C++, into this format that your hardware can understand. Now, even though your hardware really understands the language, again, the operating system facilitates the whole thing. So you're not going to run this whole thing on your own. The hardware itself works closely with the operating system in order to, basically get your stuff done. So this is cool, but what happens here is that when you develop your application and you get it translated into this form, it's pretty difficult and almost impossible to take that application all the way to its source the second you compile it. So this is what we call the binary format. When you have the final deliverable, which is the binary format, it's impossible, not really impossible, sorry, it's pretty difficult, almost impossible, but not really completely impossible. So this is where it's difficult for other engineers, especially in the security space, because if you have that sort of a thing and you have a hacker coming in with an extensive level of security, let's say extensive level of software skills basically, they're going to be allowed to create a malware that you're not going to be able to understand the behavior of. And this is where reverse engineering comes into the picture, because you need somebody who's really good with software to dissect that binary format all the way to that format that you can understand and read in order to tell what's happening under the hood. So this is for the compiled languages type. We also have the interpreted world. So the other set of languages like Python, PowerShell, JavaScript, they're popular because they're much easier and they don't have the same limitations, just like the other, in comparison or in contrary to the other languages. However, they're extremely slow. Reason is, when you develop in those languages, your application doesn't necessarily translate to the language that the hardware understands. So when you run an application, there's a piece of software that goes by the name of JIT, or just-in-time compiler, that tries to translate the code the first time you run it into that piece that your hardware understands, basically. There's a lot of variations to the flow that I'm talking about, but the idea is the language here is not going to be, the deliverable of this language, not going to be the final format that you're going to be using on the machine. So there's another level of abstraction that we're talking about here. And so this is slow, but has a lot of benefits of being able to change the code and run it at the same time. And this is beautiful because if you develop, let's say in Python, and you run it on, let's say, an x86 processor, it's not going to be a problem or trouble to take the same code base and run it on an ARM processor, let's say, or on a RISC-V processor. It's all going to work because you have this sort of abstraction that runs the job no matter which platform you're on. However, with the previous one here, compiled languages like C, C++, the second you compile for a processor, good luck running it and on a different processor. You're going to have to compile it again, which is a lot of difficulty. It's a huge hassle. Cool. All right. So let me show you a couple of things here. So .NET is pretty popular in the banking world, in the corporate world. Most companies here, especially in Bahrain, use this. And when you're developing malware, you're definitely not going to be using .NET. Reason is, it's pretty straightforward. So .NET is a combination of those two worlds that we just talked about. It's sort of a hybrid language. And the idea is, you have a couple of traits from the first world and the second, a couple more from the second world. And what happens is in the .NET world, when you develop an application, it gets compiled into this thing that we call bytecode, basically. And this bytecode program is a program that is compiled, but has many traits from those both worlds that we talked about. Okay, how does that affect us if we're talking about ransomware? Problem is, when you develop applications using this language, or let's say C#, or Visual Basic that go under the .NET platform, other people and engineers will be able to use an application that goes by the name of decompiler that is going to take your code, your application in its binary format, and believe it or not, it's going to take it all the way to its source format, which is crazy. Because if you compare that to the compiled languages that we just talked about, it is almost impossible to find it because everything gets much, it gets to its raw format, with other languages. But with .NET, because you have traits in between, it makes it much easier for developers to work in this space. However, for security engineers, it's much easier, and hackers don't like these languages. So what's the difference between C++ and C# again? As we said, C++ and other low-level languages transform application into a format pretty popular and goes by the name of PE, portable executable, and it goes something like that. But your application has multiple segments where you can go ahead basically and store your code in some segment, put the global data and everything. And now we're getting technical, but I'm going to try to tone it down again. So in this portable format, if you're developing with C++, things like the variable names, the function names, they're not going to be embedded in your final binary. So imagine you write a function that says add number 1 to number 2. If you compile it in C++, there's a huge chance that you're not going to find it. It's almost impossible to have that name embedded in your deliverable because essentially you're going to be developing that application, and when the translation happens or the compilation process, these details are going to go away. Now we're C#, because we're using a slightly different format than this PE format, which is based on the .NET Runtime Environment. Your application is going to be in this space where even the name of the function is going to be preserved. Now let that sink in for a second. If you're a software engineer, this is crazy, which means all the code that you write eventually can get in the hands of your users. Imagine you are a software engineer, you're a malware designer, let's say, or a malware programmer. You develop something and then you ship it, hoping that you're going to abuse somebody. But since your code is based on C#, it's pretty simple for software engineers and security engineers to be very specific to tear down your app and understand how it works. But you don't want to do that because you're an evil guy. So what you do is you develop your application in languages like C++, like in this case. So the logic that you write is pretty difficult to dissect and reverse engineer. Yeah, it makes it much more difficult. But again, as a security engineer, you can still get there if you have what it takes to understand low-level code like assembly and how C++ transforms the code into a format that runs on your processor. Cool. So Java and .NET, they all share the same thing that we just talked about that goes by the name of bytecode, which is a format that allows you to run cross-platform code. So if you're not coming from the development space, basically when you develop a Java application, you can take your classes, or let's say define a deliverable, put it on another platform, run it, and it's going to run smoothly with no headache if you have what we call the JRE or the Java Runtime Environment. Now, when you try to do that with C++, it's definitely not going to work because, as I said, C++ targets the ultimate platform, the beneficiary platform, in this case, your processor. x86, that's that. If you try to run the same application on another processor with a different architecture, it's not going to work out. So this is what it looks like, the comparison between real assembly on the right side and between intermediate language, which is the assembly of the .NET world. So as you can see on the right side, we have things like push, move, pop, load, and the other assembly instructions that are fairly easy to understand if you're coming from that space. But what they're trying to do is they're trying to tell the processor exactly how to do its job. For example, move, it's moving data between the registers or the actual pieces of hardware within the CPU in order to do things. So as you can see, when we pick up low-level languages, we can control the processor in great details. However, it makes building real applications that can scale much difficult. So most programmers don't deal with these languages. It's for a different set of audience types. And on the other hand, intermediate languages here, and the intermediate language, which is the assembly format of the .NET world. Remember when we talked about how functions names are preserved? Well, there you go. This is a reverse engineer version, and you can see compare 1 and 2. So the name of the function actually comes into the format of the binary, which is crazy. So you're preserving some of your source code when you're developing applications. Cool. So what happens is I'm just going to show you a couple of examples here. All right, so let me just share a couple of things here. Okay, so this is what we call ILSpy, which is an application pretty popular for dissecting .NET applications, your typical Windows applications. And believe it or not, now this .NET platform has grown so much that even Linux users are using it because Microsoft is now very neutral and it loves the Linux community. So I'm going to be opening a file, but this time I have a couple of demos here, and I'm going to go for a demo application that I have. Okay, so I have gsyncit, which is a very popular and a sweet application that people use in the Outlook space. So I'm just going to go for this library. Imagine I'm taking Dropbox library. Let's see what I get. And check this out. Oh man, now we're talking. See, we got the name of the classes. Now, if you're a developer, I'm sure you're freaking out now. Yeah. So you got the name of the classes, the name of the services, and the name of the, you know, even, oh my God, check this out. Consumer key, consumer secret. Oh, I should report that to these guys. Seriously, I just witnessed that here. So check this out. So you can see a lot of stuff in here, and this is frowned upon. You don't want to do that. So most people in the malware space never use these languages because you can easily do that. And you know what is so special about it? This is somehow different from what I had in mind for this session today, but let me show you. So imagine I want to do something different. Imagine here, check this out. You have this set value, this specific instruction, and I want to go ahead. I want to change this 9999 value or whatever that I have in here. Okay, so imagine I have a binary that I want to change the behavior of. Okay, so what I do is that I have a specific and a cool plugin called Reflexel, pretty popular. And when I enable it, I see all of the instructions here in the .NET form in this IL format. Remember this IL format that we talked about, which is the assembly format for the .NET world. If you go here, check this out. This is crazy. I can change this 999. I can do actually here. Let's see. Let me just do. Let me just check how I can edit this guy. Yeah, got it. Sweet. So I can do edit. Let me just do edit here. And I can basically change this value in an application. So think about that for a second. This means you don't even need the source code in order to change some of the behavior. And this is where making key generators and making, getting serial numbers, illegal serial numbers to work on specific applications. It all starts here. So for example, I can change that to 8. I can do update, and there you go. I changed everything, and the cherry on top of the cake is that when I choose this library, I can now say save as, yeah? And now I can save this patched version, and I can use it in my real application. So this is what happens when you use a .NET application. Pretty straightforward, doesn't take a lot of brains. You can do it even, with a couple of things. Now, on the contrary, I want to show you another cool thing in here. So it doesn't mean that all hope is lost, honestly. If you're working in the .NET space and you have a commercial product that you're trying to hide, just like these people here, Hotspot Shield, which is a very popular VPN client, check this out. When I try to do this, what am I going to get now? Let's see. What is this now? Now, this is a somehow mangled, crazy text in here that I don't know how to work with. And that means that whoever created this .NET application, be it a library or a GUI application using exe, the exe format, use an application that goes by the name of obfuscation. And obfuscation is this process of taking your application, your final deliverable, and changing the code in a very complicated format. So when people like me try to use ILSpy in order to dissect the application, they won't be able to do so, and it gets very mangled. Now, this can also be reverse engineered if you're really, really smart, but it takes a lot of time, and sometimes it might not be really that efficient for you if you are a security engineer working in this space. So I have never come across a malware solution that uses .NET, or at least, by really clever people so far, because this is, let's say, much easier to work with if you are in the security space and you're trying to understand how these things work. Cool. Okay. let's see what we can do. I want to show you another thing here. Android is probably a developer's favorite, you know, if you're a sane person, of course. So Android is a wonderful platform because, and the trick is, because it runs on the Linux platform, on the Linux operating system. Well, now you know if you didn't know that before. And so everything in the Android world really runs basically on the Linux kernel, which is a testament of how Linux is really powerful and how it took the world by surprise. Now, when you run an application on top of the Android platform, you're most likely going to be using two languages, either Java or Kotlin. All right, so I have this application here that goes by the name of Java Decompiler. I'm just going to showcase it to you guys, and there it is. Okay, so this is an application pretty popular also. It's called Java Decompiler, and you can find it online. I believe it's open source. And what you can do is you can basically just load an application or a class, okay? So I don't have classes here, but if you're coming from the Java world, you know that you can take class files, a jar, whatever it is. Now your application on Android, even though their extension is APK, they're basically a zip file, they're an archive. So when you take that archive and you open it, you're gonna find, a DIX file. And there's an application that allows you to take that DIX file and extract the classes inside. And there's a lot of tools. And one of those tools is called, for the people who are interested, DIX to jar. So DIX to jar is gonna take your DIX file, which is the binary format basically for the Android platform, if you're coming from that space, and it's gonna convert it to a Java archive, which is the jar file format, the very popular jar file format. So I'm sorry I don't have it in here, but you can check out my other sessions on my YouTube channel. You can just go to YouTube, right? Ameen Altajer. You're gonna find the demo there that I'm talking about, and you can see it in some of those videos. But essentially the idea is when you have that thing and you open the jar file, you're gonna find the class files, and when you just put it in that application here, the Java Decompiler, you're actually gonna see the code. So it's exactly the same case with the .NET platform, except that you can do it now with Java, okay? If there's one thing that we learned today, that would be that C++ is really popular by malware, designers and such, because it is extremely difficult to dissect, the code of that. You need really somebody who's super talented in the software space, and you need, to dissect it first and understand how it works, which is much more difficult when you compare to other languages and other platforms. And also it's pretty efficient as well. So it runs fast and it's here to stay in other things as well. Now, a very cool trigger that I want to mention here, you know that most ransomware applications, when they try to encrypt your files, they're using a sort of mechanism that goes by the name of PKI. Now, let me break it down for you if this is your first time hearing the word. So PKI stands for public key infrastructure and is a fancy name. But what it means is essentially, when you try to encrypt anything in the world, you have two methods basically to just keep it simple, okay? And I'm just going, miles away here trying to make it simple. So bear with me for a sec. You can either use a regular password to encrypt and decrypt the same data, or you can use the PKI infrastructure, which is this fancy term that tells you that you want to have two different keys, two different passwords, one for encryption and one for decryption. Now, a hacker that loves malware will use the second form. And the way they do this is that basically they generate a public key and a private key, two things that work together. So you can encrypt with one and decrypt with the other. And then they use one of those keys, most likely the public key, to generate another key. But I don't want to go into the technical details, but the idea is when you're trying to encrypt somebody's past files, you're using, in a way, the public key. And so the only way for you to decrypt your data somehow is to get a specific key coming in from your hacker. So this is how ransomware works. Essentially, when you try to encrypt something on the target machine, in a way, your key might reside in memory. So this is why you've probably heard, if you've been struck by a ransomware, don't restart your machine. There's a huge chance that you can recover that key and get your files all together without paying the ransom. Now, if it's a dire situation, it's most likely not going to work because the design of the application is much more elegant and you need to actually get a specific key from the hacker online. Now, what is so cool about this PKI setup is that the attacker doesn't need to send anything online, which is really beautiful. So this is a one-way street. You can just send malware somehow, either through attachment or so. And when the victim runs the application, they're going to be struck with this, and there's no way that you're going to find this key that helps you, with the decryption. You have to really contact, this somehow infrastructure that the attacker has in order to decrypt your files. So this is basically for how things are done in that space. Now, the funny thing is, though, some of those ransomware designers have either deliberately created bugs in their code, or they really messed up big time, when they develop their ransomware applications, because there are a lot of cases where you pay the ransom, you get a key, but that key doesn't work. And I've seen that, I think, with Pitya or not Pitya, I forgot which one of those ransomware applications, ransomwares. You can look them online. So the application itself was written in a wrong way, that utilizes the key when you want to decrypt. So essentially what I mean is when you pay the ransom, you don't get your data. Not because the user or the hacker, in this case, doesn't want to get or is giving you a wrong key, and that is because when they give you the key, the decryption was not written in the right form. So in either way, you're not getting your data, either by paying or not paying because of a specific bug in the ransomware. Talk about how bugs are really apparent in every piece of software that we have. Yeah, cool. All right. So yeah, no runtime environment for the .NET platform, for Java, and for Python and C++. Everything runs natively on the hardware through the operating system. So we've seen that. And I want to showcase one last thing here. And that is, I want to show you how difficult it is to really debug, or let's say deassemble C++ applications, okay? All right, so I'm going to be showcasing an application called Oli Debug, which is an environment that allows people to somehow debug C++ applications or native apps, okay? People say hi to Oli Debug, which is a nice application that allows you to see how C++-based apps are working. And there's a lot of information to really absorb here, but don't worry about that unless you're really a low-level engineer. But here on this side, you have the assembly, as you can see, and these are the places in memory because memory is numbered. And then here, the analysis of this application, Oli Debug. So these functions, get module, handle A, these are functions coming in from the Windows OS. And this application is so smart that it can figure out that this call here to this location in memory is trying to call this function. If you're a security engineer, you're going to rely on a lot of applications like those in order to understand how the behavior works, of those ransomware applications. And if you read the documentation, or let's say the findings of those engineers after dissecting Pitya or not Pitya or the WannaCry ransomwares, you're going to find them always looking at screens like those because they're trying to understand bit by bit here how the assembly works in order to, explain the behavior of the ransomware. Cool. So this is Oli Debug, pretty awesome to work with, still extremely difficult. As we said, Oli Debug is awesome. Try it out if you're interested in that space. You also have Wireshark. So Wireshark is this network sniffer, which allows you to do some sort of reverse engineering. It's pretty popular and extremely useful in the ransomware space because you'll be able to see what your computer sends out of your network device, out of your network card, all the way to the internet, to the public internet. So you can see stuff going in, stuff going out. And if you have TLS or SSL encryption, there's a huge chance that you're not going to be able to do that. So most connections going over TLS are hard to dissect, but not impossible. You can basically just install a certificate on your machine, a root certificate that can then lie. The idea is there are programs like Wireshark and Fiddler that allow you to go and check the kind of traffic that go into your machine and that go out of your machine. And that really helps a lot, whether we're dissecting ransomware or just regular applications, okay? So this is the concept of obfuscation that we just talked about, where you keep things in a format that a user can understand especially in the .NET space. Yeah, so we've seen obfuscation as well. And I just want to leave you with that note before I get any questions. So remember, with great power comes great responsibility. And I've actually stole that from the Spider-Man movie. So, don't tell anyone. So yeah, there you have it. This is ransomware. If you're interested, this is basically reverse engineering. And if you're really interested, there's a tool that I really love. It's called the IDA Pro, basically IDA Pro. And this is one of the most useful books that I've read about that topic. It really tells you how to understand software from a lower level. But again, tread carefully. It's extremely technical, not for the faint-hearted.